low, let's say D high. What does D high stand for? Derivative of the high. So low D high minus high D low. What does D low mean?
Derivative.
Derivative of the low. All over low low. Low low meaning I multiplied low times low, low squared. It's a phrase though that's easy to remember. It's like SOHCAHTOA, right? It's like SOHCAHTOA. Or it's like all students take crack. I mean all students take crack. It's like that. So it's low D high minus high D low over low low. It's like the seven dwarfs meaning, I don't know. Low D high minus high D low. But some people like it. I get some students who hate this. They're like, I don't like that. And I still don't understand it. I have to show them D high means what? Derivative of high. What's D low mean? Derivative of low. I like this though about it, everyone. If you remember this, you won't do it backwards. Because I'm going to show you a common error. This happens a lot. See the M and N? Students write this on their paper. Can you get the error? Close. When they mess up. Doesn't it look like it? Yeah. It's backwards. This should be there and this should be there. Do you see it?
Mm-hmm.
So this phrase helps you remember you start with the what? Low. Derivative of high. Minus the high. Derivative of low. Low, low. Here's another one. No one's going to like this. This is what I was taught. Bottom times derivative of the top minus the top times the derivative of the bottom all over bottom squared. Kind of lame, huh? That's the phrase I memorized. That's the frame I memorized. Everyone way back in the day, Bowie High School. Right? Bowie High School back in the day. Bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. Did not hear this. Did not hear that. Heard that from friends though when I was in college. I was like, ah, yeah, I like that. I like that. I never heard that before. So let's try it. Now, do you like to list these off to the side, then do it? I don't think so. I think a lot of you can probably just what? Start cranking it out. Here we go. Long fraction bar. What's the low?
1 minus 6.
So the whole thing. Okay, I'll put a parentheses around it. You agree?
Mm-hmm.
Put a parentheses around it. I know it wasn't there originally. You get a parentheses because you're going to multiply this on. There's my low. Now, what's D high?
3x squared.
Some students like to label these. They put in here and they're like, okay, this was my N, this was my M prime, this was M, and this was N, right? They like to label this stuff. And then is it plus or minus?
Negative 2x. Oh, sorry,
It's a
minus.
subtraction sign. The product rule has the plus, right?
Yep.
Shit. The product rule has the plus. Minus, low D high minus high.
X cube.
Right? X cubed. Low D high, meaning derivative high, minus high D low means derivative low. What's the derivative of the low?
Negative 2x.
Good job. Do you all agree? I'm looking at eyes. Just let me know. I don't see that. Derivative of this. Derivative of that would be 0. But then the derivative of this, you got to power rule. Derivative of the low would be negative 2x to the first. Good? Yeah? Yeah, so if any time, any of the little ones, if you're going, I'm not seeing that, just let me know. Because I know we just learned power rule. Sometimes it's hard to see that power rule. So there's n times n prime minus n times n prime. Some people like the label. And then it's all over low. Everyone, I'll say this 4 times in a row. You ready? Never expand the low. That's once. Never expand the low. What do I mean by expand? Foil. Never foil out the low. Last time, never ever expand the what? Low. I was so funny. Students will do it. I think they'll have to like multiply it all out and stuff. You know, foil. There's no need for it. You'll never want to do it. Leave it like that. Leave it. But clean up the top. Get this clean. Get that all nice and neat. But let's leave it. You start foiling it, you'll miss that you can probably simplify it somehow. So never foil this out, right? Ever. Leave it. You're good. Low done. You just put a square down there, right? Yeah, all right, now, distributive property, be careful. What's that times that?
3x squared minus 3x4.
So 3x squared times 1 is 3x squared. Negative x squared times 3x squared is a negative 3x to the 4th.
Mhm.
Very good.
Plus 2x,
I see a minus and a negative.
so plus
You all see that? It's gonna become a plus. 2x to the what power?
4.
And do you see like terms in the numerator?
Mhm.
Yeah, you're gonna want to simplify that. That's it. But the bottom, don't boil it here. What's x squared squared? 1 minus x squared squared. Do not boil that thing out, ever. All right, final answer.
Will be 3x squared minus x to the power 4.
All over?
1 Lolo.
So far, so good?
Mm-hmm.
Now, is anybody curious if you could simplify that?
Yep.
You might be curious, like, oh, maybe I can factor something out of the top and really, really clean this up. It's worth a try, right? It's worth a try, but maybe we won't get anywhere with it. Would you agree? Well, everyone, we're done. We got it. Looks nice and pretty, but you're doing this with me. We're studying the numerator here, going, and I wonder if I factor out something out of here, it might tidy up the bottom. Let's explore. So you're saying factor out an x squared, right?
Mm-hmm.
Maybe we can, but maybe we can't. You factor out x squared. You're left with a 3 and a minus and a...
X squared.
And I'm sorry, nothing will really cancel, huh? We gave it a shot, right? So what I'm saying is both of these are great. Both of them are great. This is better in chapter 4. This is fine for now. That would be minus 1. Because someone didn't add like terms, right? Does that make sense?
Mhm.
It's always good to examine whether you can factor something. You never know if something's going to like, oh, I can knock 2 of them out or something. All right, here, try another one. How about x squared? I think you got this down, but everyone, it's something about distributive property. There's something about distributive property. No. I don't know what it is. It's like the last one. Would you try that? Start to finish, all the way to the end. Hey, what's some good websites for support? If you ever want to check these, and you go, well, look in the back of the book, but it's an even problem, and you want to check something online. Does anybody here know Wolfram Alpha?
Mm-hmm.
Yeah. Great site. Only thing is, how do I spell it?
WOLFRAM.
And then FRAM, and then alpha, right?
ALPHA.
There you go. I don't know if is it .org or .com. .com. And everyone, outstanding. I encourage every student in here at some point during the course just to go there. It's like it's a computer engine. I mean, it can find information in the entire world about anything, but it really can do computational stuff. So you type in differentiate y equal to x squared plus 1 divided by x squared minus 5. You know what it'll do? Give you the answer. And I don't know this. You probably know this better than me. Do you have to pay for it to show all the steps? You do have to pay for it? What do you get for free?
No, not everything.
What do you know?
As far as I'm aware, you have to pay for it for the website, but the math lab told me that if you download the app, which is $3, you get all the perks.
Now, is it a one time $3?
Yes?
Just one time, you pay
Yeah.
$3 and you get the app, and then the app works.
I think so.
Outstanding, everyone. I'm saying for support. It really is just, it's neat to see this stuff. It's when you're like, I don't know if I did this right. And you're like, I don't know the answer. And you're just like, hold up, I'll get this online. You go, where should I go? You know? Go right to Wolfram Alpha and just type this stuff in. That'll give you, you know, something weird. You just type the, look, differentiate, then type this. You wouldn't have to do the y equals e. Great stuff. All right, give it a shot. Or what calculator do you have? Do you still have the 8, anybody got an 89? I know we can't use this room, does anybody have one? You
Not with
can,
me.
I would just, but there you go. They have 89 calculators, check those. Because they will do it. And when they have a CAS, CAS, stands for Computer Algebraic System. And so TI-89 or Bob, TI Inspire, you had that calculator, you had a brother or sister had it, go, can I use that real quick? Go in there, and go find the differentiate, and you type it in, it's really easy.
Actually, 92. That's
92?
On eBay, it's really cheaper, like 30 bucks.
Really?
Yeah,
Yeah, they're usually cheaper.
the higher.
Everyone? They're usually cheaper because there's not a big demand for those. It's the 83s that big demand, everyone's always trying to get them, so they're priced higher. Naval Academy, they use the Inspire. Half their assessments are no calculator and calculator. The Inspire is like the, you know, like the 89 and 92 and stuff. They used to use the, they're the only college I know across the country ever use it. It's called the Voyage 200. It's TI calculator, but it looked like a computer. It's not that great. It's like the 89, but it's hysterical. Whenever people see it, they go, oh my gosh. They think it's like this supercomputer or super calculator. And everyone is, the 89 is just as good as it. All right. Low. What's D high?
2x.
Low D high. What's high?
2x.
No, negative. Yeah.
You all agree?
Yep.
So far, so good? Low. D high means derivative high.
Mhm.
Minus just the high times D low. What's derivative low? Another
2x.
all over, don't foil it. Don't expand it. Was that what I good then? This time I didn't label though. So you might find it like, I like to put M and N primes and N and N primes and all that stuff.
And where did you get the 2x?
Oh, you bet. So I'm gonna go in here and I'm gonna label these. Like here, if that's like M, that's M. If you don't like
Yeah.
those, you can use letters. Maybe I should introduce all the letters that you prefer. You know, there was like an F here. You can use that.
No, I understood that, I just didn't know where you got the 2x.
G times F prime low D high minus high. And you go, where did this come from? So I'm taking the derivative of that thing. Now let's derive this. I have to do
Oh,
power
just
rule.
take the
2
put it in front of
X to the first, good, and what happens to a plus 1? Derivative of any constant is 0. Do you agree? So hey, I know I wrote it like this, but do you agree? Amber, it was really 2x plus 0?
But the 0 doesn't exist.
Good. And stop me at any time. You don't see something like this, go, wait, I'm not saying that. Because that's usually what it takes. You'll see it and go, oh, now it makes sense.
So you just have to use the power rule for that.
You do it a lot, don't you?
Yeah.
In between these little rules here, you use the power rule like over and over and over, unless it has e to the x. Because e to the x, the derivative of e to the x is just e to the x.
Okay.
You got y equals e to the x, the derivative is just e to the x. Hey,
Can you factor before you distribute?
yeah, this is interesting. Students do some interesting things here. You said factor, you can do that. That's how you see it, and that's good, Kelly. A lot of students don't see factor there. They do distributive property. They get their like terms and they get the same answer as you. But do it your way, because that's what you saw. You noticed, hey, they both had 2x's. You could factor out a what? A 2x. Most students see distributive property, and they go, that times that is 2x cubed. That times this is.
Negative 10x.
Now I want to show you what happens on my test. Is everyone ready?
Yep.
Every time.
Oh,
Every time. Everybody see it?
yep, it should be negative.
Everybody see it?
Mm-hmm.
It's hidden now. I get this all the time in the numerator. That's why I want to emphasize this. I like to highlight the big errors. You know, we got the rule down, all this stuff. There's something back from algebra days, distributive property. You distribute these to this, but what's that?
Negative.
That's got to go to both parts. So you got a 2x cubed with a negative, but this would also be a what? A 2x with a... Does everyone see that? Does everyone see that? It's called distributive property. I know, it's back old school algebra, but it's something that misses, it's the common error.
Can you also factor the X squared minus five?
You sure could. Hey, do you see any like terms? Oh, now I did all that. Where's the like terms?
2x cubed.
What's the final answer?
Negative 12x.
Easier? Should I FOIL that out? Should I expand that? Never. Never. Never, ever, 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 ever. Hey, if the denominator had an x squared minus 5 to the squared, you square that, you get x minus squared minus 5 to the fourth, right? Cool. Is that okay with quotient rule? Good. Did you know every derivative rule now, except for one? But the one we haven't done gets its own day. Do you hear me? One day. You don't do anything else. I might go over one day. Unless you get sick of it, I might even go over another day. And you're like, no, we've had enough of this rule. It's called the chain rule. And it is the most important rule. I will not move beyond 3.4. I will not rush that section. I think the textbook problems are pretty lame. There's maybe a good handful that are good. I make up like some problems just to say, here's some practice. You suggested this, but I already had some. I'm like, here, you want to see 25 problems you need chain rule on? Here they are. I didn't put answers to them though, so you can be like, hey, can I check this? We'll go over some answers. You know, it's just the key rule. I'm not even touching it today, right? Cool. But you got quotient rule down, you got product rule down, true? Let's move into this now. I think it's very important. We can get chain rule its own day. Let's hit all the trig derivatives. Sound good? How many trig functions?
6.
6. You got your SO, cot, tail, and then you do all the reciprocal buddies, right? Sine, cosine, tangent.